эти моменты слабо акцентированы.
I believe that all the experts know it, but maybe we're not highlighting some of these issues enough. Let me explain what I mean. When we're talking about decarbonization and energy transition, we're often seeing lopsided, very polarized approaches. Some people tend to be very alarmist. Maybe some people are ill-advised, or they have vested interests. Has not been the case so far in this conference. Most speakers today have been pretty pragmatic about it, saying, yeah, well, we need to decarbonize, and this is how we're going to do it, and these are our short-term plans, but we also have long-term targets. But you know what? When I started going deeper into the subjects, I found it to be so conflicting, and it does trigger lots of conflicts, by the way.
Но я бы хотел о чем просто вот все-таки сказать, что очень важно здесь, вот если попытаться...
Hopefully, the conflictogenous, so to speak, or, the nature of this discussion will generate so many conflicts now, hopefully will change over time. And I think it's extremely important for everybody who's getting emotional about those subjects to remember that all our estimates and assessments are still very much ballpark estimates. They are very rough. And therefore, it's easy for us to have like high-level agreements, abstract agreements, but specific targets and specific measures are pretty difficult to develop and elaborate, given how much we really don't understand. I think everybody understands that decarbonization and energy transition are extremely expensive. Well, actually, there is an inflection point. They're either very expensive or very, very expensive.
Оно опирается на то, что у нас будет довольно серьезный прогресс в технологиях, которые там сильно нам...
And even if it's just expensive, it sort of assumes that we will have all the technologies required for the energy transition. And we're hoping we will have these technologies, but this is not bound to happen. I mean, it's not at least guaranteed to happen. And without these technologies, energy transition will be impossible. I came up with this analogy one of these days, that for the world as a whole, energy transition is like working a month without being paid our salary. And it may actually be a conservative assessment. And the economists should understand that this is a horrible piece of news for most people. Many people will not be prepared to pay this price. Now, that's an average thing, right? The state of Oregon found it very easy to assent to the Glasgow Agreement because they've got so much hydropower. But it won't be the case for some people. Some people will have to pay their 2 or 3 monthly salaries a year for this energy transition. In fact, decarbonization means going away from the principles of market economy. We're sort of imputing a value to a particular social boon, which we don't really know how to quantify. Now, you can call it a boon or you can call it a necessity, but we are using an imputed value here. We're saying that's the price. There will be lots and lots of economic subjects who will possibly counter that, and they will have their arguments for that. And it's just part of the issue here. There were other issues raised, and we have sort of forgotten about them. The point I'm trying to make is that the more we progress towards decarbonization, the more acute these issues will be. Like, who's going to be paying for the energy transition? Is it the consumer or the producer? Well, so far, the consensus is that it should be the producer. But, when the rubber hits the road, I guess we'll have to reconsider it. And what about the industrialized countries? It's naturally, the freeloader issue, so to speak, taken to the power of two. And it's a well-known fact. Like, we all know the countries that have successfully industrialized and obviously they haven't paid for their carbon emissions. And the developing countries are going to actually demand that they do something about it. And the balances for individual countries, the balances of losses and benefits, or the calculations, comparisons of losses and benefits, we still don't know how to perform them. And they will differ very much for different countries. I'm not even mentioning SDGs here. So how do we come to an agreement? And most importantly, how do we ensure enforcement? These are the biggest conundrums, if you ask me. So I guess that in this context, we can easily say goodbye to the 1.5 degrees pathway. But I'm afraid that even 2.4 degrees pathway, which seems to be, the consensus about where we're going to get with the Glasgow outcome, even 2.4 pathway sounds like slightly optimistic. What then should we be preparing for? Should we be preparing for reduction in emissions, or should we instead be preparing for adaptation? We are saying so little about adaptation to change. And yes, some things we can do in order to reduce emissions will help us in terms of adaptation, but not all of them. Well, I guess that if we establish a single global government, which will, use strongman methods to drive change, we may succeed. But I actually am afraid that even with a dictatorship on a global scale, we'll still be seeing like 4 degrees centigrade increase in annual average temperatures. I believe that political systems, not at the national or country level, they're so diverse, they are so misaligned, that I found it very difficult to believe that, the agreements will be enforced. I think we need to be extremely optimistic to actually take politicians' words for it. And we are talking about climate here, but what about the demography? These two factors will start sort of agitating each other. Well, we may actually go the way of Asian countries adopting one woman, one child policy. Will it work? I don't know. I think it's a very challenging situation. And it's sort of surprising that most of the discussions we're having about it are sort of relaxed. Maybe because we're not going to be the ones paying for it, because it will be our grandchildren paying through the nose for it. But let's remember that energy transition sort of imposed by the decarbonization agenda is a kind of counter-revolution. It's a counter-revolution compared to the current vector of the development of humankind. All the technological, in fact, even macroeconomic revolutions have been propped up by the humankind mastering new types of energy. With the same kind of effort, humans learned to get more and more energy. Well, we can also argue about energy density, but let's not do that. That's not the case with renewables. Renewables at the moment are still more expensive. And as long as they stay more expensive, it will be a counter revolution, at least from the economic perspective, regardless of how we feel about it. So if we really want to be, constructive about decarbonization, we need to make great progress in terms of technologies. And I'm not even sure we will be there because, in essence, we need a proper technological revolution. So that's the point I was trying to make. And that's what we should be focusing on. And Alexander mentioned it. We need something, on the scale of the space race. Thank you. Thank you so much, Vladimir. Now, the colleagues here have been, doing this kind of research for a long time, have been listening to you with great interest. And you sounded like you have been, reading off the pages of the research we've been doing for the past 10 years. And we've been doing our calculations and our conceptual analysis. Unfortunately, however, it's not the economic calculations, it's not the hard figures which drive changes, but rather politics. Difference. Boris, if I may ask a question, I would like to take 90 seconds. Sergey, I'm sorry, but it's 90 seconds, okay? I absolutely support this idea that we need to be pretty reserved and calm whenever we hear about specific pathways, be it 1.5 or 2.4 or 2.7, because the climate system as such is so complex. I mean, we do develop a long-term forecast for decades or even a century. But these are probabilistic projections. They are not really forecasts because there are so many unknowns there. There are so many variables. And I will give here a very simplistic example, and I'm sorry for barging in. So at IPCC, in our latest report, we actually had a chapter on COVID-19. Obviously, it was not about the need to get vaccinated. What we did was like this. We all noticed a significant reduction in emissions in early 2020. So we wanted to assess the impact of this reduction in emissions on global temperature. It was actually very difficult to perform. But our calculation showed that the impact was very minuscule. The stuff that had been accumulated in the atmosphere was colossal enough. There was indeed a minor reduction, but the world didn't really notice it. So we did measure minor decrease in temperature at a certain stratum in the atmosphere. But we also registered, an increase in black carbon. Oh, no, I'm sorry. There was a reduction in the emissions of black carbon and other minor pollutants, which actually led to the fact that people said, well, we see clear skies now. But this is a different system. It's a system with a much lower inertia. The feedback happens much faster. But I hope that this single story shows how complex this whole system is.